Oh, all right. All right. So for the first question, we just had to do the fundamental set of solutions and write down the differential equation for y to the fourth minus 16y equals 0.
So we started by finding the roots. We got like the equation like r raised to 4 minus negative 16 equals to 0, and then we equated it to r raised to 4 equals to 2 raised to 4, which means we have four roots, 2, negative 2, and positive 2i and negative 2i. And
I can go, yeah.
okay.
And then we kind of just at the end for y of x, we combined them all together. So we got C1 e2x plus C2 e minus 2x plus C3 cosine 2x plus C4 sine 2x.
And then for the second one, we had to find a general solution of an ODE using undetermined coefficients. So we started with y double prime minus 2y prime minus 3y equals 4x minus 5 plus 6x e to the 2x. So first we went by, sorry, finding our R value. So it ended up being R is equal to -1 and 3. Then we found our characteristic equation, which was C1e minus, uh, I'm sorry, C1e to the negative x plus C2e to 3 to the x. And then I then separated it and found the particular equations into two parts. So first it was y of p1, which was equal to ax plus b, which was our 4x minus 5, and then y of p2, which is the 6x e to the 2x, or e to the 3x, sorry. Then we went on to find the coefficients. So first finding A by setting the equation equal, I'm sorry, finding the double derivative of yp, the single derivative of yp, and then yp itself, yp by itself, um, canceling everything out, trying to find our A value, which ended up being -4/3, and then doing the same steps to find our B value, which ended up being 23/9. Next, went into the exponential version of the question, or portion of the question, so our YP2, which was the 6x e to the 2x. That was similar to just having taken the e to the 2x out will be the same as having like an mx plus b scenario. So then we're finding the derivative of yp prime 1 and then yp prime 2, or excuse me, yp2 prime and yp2 double prime, excuse me. Um, Finding each of those, plugging it into the equation, and then factoring and simplifying everything, ultimately ending with -3 mx plus 2m minus 3b. Then plugging that into the original equation, setting it equal to the 6x e to the 2x, and solving for m, which ended up being -2, solving for b, which ended up being -3/4, giving the second YFP equation, which was e to the 2x, uh, parentheses, -2x minus 4/3. And then after that, combining and factoring the equations together, and putting the YP1 and YP2 together, you ended up getting negative -4/3x plus 23/9 minus e to the 2x, parentheses 2x plus 4/3, which simplified to our ultimately giving us our y of x equation, which was equal to c1 e to the negative x plus c2 e to the 3x minus 4/3x plus 23/9 minus e to the 2x, parentheses 2x plus 3/4. Or I'm sorry, 4/3.
You want to do 3 or I can do 3.
You you can do three and then I'll do both.
Okay. And for number 3, we just had to find the form of the particular solution. for y to the second power minus 4y equals x squared sine 2x plus 6x plus 7 cosine 2x. And we didn't have to solve. And we just had to find a polynomial for this, which was ax squared plus ax plus a, and then sine 2x. And then for 6x plus 7, we got, and cosine 2x, we got b2x squared plus b1x plus b naught cosine 2x. And then for at the end, the whole solution, we just added those together, which gave us a2x squared plus a1x plus a naught, all parentheses, sine 2x plus parentheses b2x squared plus b1x plus b naught times cosine 2x.
And finally, we had to solve the ODE x squared y double prime minus 4xy prime plus 6y equals x cubed with a given y of c1 x squared plus c2 x cubed. So we start off with our y of c here, and we have to make sure that this is just, there's nothing multiplying by this y double prime here. So we multiply this equation, or divide this equation by x squared. At which point we can get our Wronxians, which are y of 1, y1, y1 prime, y2, y2 prime. And then here we have our first Wronxian W1, which is 0 times this, which I'm blanking on the name of, times y2 and the derivative y2,
We're
y2
just
prime.
solving the determinant.
Yeah,
Yeah.
and you solve the determinant here. Here again, you have your you have your um y1, y1 prime 0 times this. You go through the determinant, which you just do this. So you get the determinant of w is negative x. Um, wait, or excuse me, x to the fourth. The determinant of w1 is equal to negative x to the fourth, and the determinant of w2 is equal to x to the third. At which point you find your u1 and u2, which is just the integral of w1 over w for u1, and u2 is the integral of w2 over w with respect to x on each. At which point you get negative 1 dx and 1 over x dx, which is, of course, negative x for u1, and u2 is the natural log of x. To find y of p, you have to multiply y1 by u1, which is negative x cubed. And to find the second part, you have to do u2 times y2, which is x cubed, times the natural log of x. And finally, you combine your y of c and y of p to get your general solution of y of x equals c1x squared plus c2x cubed plus x cubed times the natural log of x minus 1. And that is everything.
That is everything.
Thank
Thank
you.
you.
Thank you.